Our next big block is about DNS, several presentations, and Taras will be the first one speaking. He has introduced himself, so he will be sharing about DNS stack. Hello. I wanted to share about DNS security. That's quite a vague name for a presentation. Quite often I hear that people believe they are protected if they have a DNS stack, but to understand how it works together, I will try to introduce it in some detail. So, first, let's recall some terminology. Quite recently, I had a correspondence with someone who is using internet for quite some time, and they said they were using Raspberry for their internet server. But okay, that's great, but I needed to ask additional question: what exactly is working on Raspberry? And it turned out that everything was on Raspberry. So here there are user devices. So they have the so-called stub resolver. As a rule, it's a library which uses applications on user devices in order to resolve names. Next, we have this stub resolver who helps to contact recursive resolvers. And right now, they can belong to internet service providers who provide you access to the internet. So together with providing you IP address, usually they also provide the address of the resolver they use to work with names. And also there are public recursive resolvers available, and 111, 8888, etc. Also, recursive resolvers can be also available on your computer. If you are using a Unix-like operational system, nothing prevents you from having a resolver right there. And also there are authoritative service, and they are being contacted by recursive resolvers. The word recursive stems from the fact that they start from the root servers and they go down and down, and then they get a reply to request they have said. So we will be speaking of recursive resolvers and authoritative servers. Now, what is DNSSEC? It is the situation where the final user is contacting a recursive resolver, and if it is a validating resolver, it has a trust anchor, which enables to test, to check the answer from the root authoritative server to make sure that it actually came from the valid server. And also, such recursive requests provide trust anchor for the next level of authoritative service. Such checks continue ad infinitum. And in the end of the day, we get the final reply. If the recursive resolver is validating, it enables to make sure that the reply, the final reply, is fully in line with what is written there. So there was no counterfeit on the road. This is everything it protects you from. If, for instance, here there were some intrusion, then you are getting a wrong result. Although you have a validating resolver. But if your stub resolver at the user end is quite simple and stupid, you can easily abuse it. But also, just to give you the understanding how to check if the resolver you are using is a validating one, there is this domain name. And if you go to this website and see the content, it means that your resolver is not a validating one. And if you are using a validating recursive resolver, you will not see this page. Next, DNS over TLS and DNS over HTTPS. This is also about protecting this channel between the user and the recursive resolver. So it is quite simple with DNS over TLS. Just like with any SSL layer, the minimal protection is the safe channel between end user and recursive resolver. But if it is an enterprise network, we need to increase the protection by means of checking the certificate of the recursive resolver. So not only the channel is protected, but also we are using if we are asking the right entity. As a rule, the DNS contact scheme looks like this. The end user is getting the address of the recursive resolver by DHCP and working on the resolving of names, it contacts the website. Now, with the emergence of this DOH or DOT, providers do not support this yet for the most part. Quite often, if you use DOT or DOH, the provider only provides you the channel. And the recursive resolver is, as a rule, an address that you set on your own. And first and foremost, the question is what software supports this work over DOT. It's still an open question. And even if it does, as a rule, this is a task for public recursive resolvers, and I will further mention that some of them also support DOH as well. So this is more or less what's in use right now. So here you can see this simple illustration, DNS over TLS and DLS over HTTPS, and also the simple DNS, which is quite transparent and susceptible to sniffers. DNS over TLS, it's closed traffic, but with a separate port. So what is happening in the communication with the recursive resolver, we cannot see, but we can see the DNS traffic. We can see that there are these DNS requests. And if you are using DOH, it is a traffic which disguises itself as HTTPS traffic. So the provider, the operator, will not even see that these are DNS requests. This is quite simply HTTPS traffic, and that's it. And one cannot see DNS there. So here are some of the issues or questions that arise. I have started discussing some of them. So with DOH, it is fully closed from the administrator, from the provider. So the provider does not know that DNS traffic is happening there. If it is DOT, at least you can see that this is DNS traffic. If you consider the model under which DNS over HTTPS is being implemented right now, it is implemented in browsers. It's not using the system library. It is contacting with its own means to DNS servers, to the recursive servers that provide response at port 443 on DNS. And this way we are not using the DNS that is provided in the system, but we are using the DNS which is specified in the browser. And the confirmation of this, the result of this, is that each application has its own recursive resolver. Theoretically, this should not happen, but in practice we can implement this, that one and the same name can be resolved to different IP addresses for different applications. And it's, for instance, because of the lack of synchronization about one application asking one way and another application asking another way, and this is the result. For DOT, we do not see that yet. And the issues that are the same for both protocols. First of all, if we consider the browser implementations, we need to have some public recursive resolver. So you can have it as your own recursive resolver. It does not take any serious money or skill, but this removes the recursive resolver from the provider. Which also means centralization and concentration of recursive resolvers at places like Google, etc. So the way they use this data, that's a separate issue, but overall this centralization and decreasing of the installed soft, this entails some decrease of competition, decrease of stability, so nothing good is coming out of this. One more issue here is impossibility for ISPs to influence the results of the requests. It is both good and bad. On the one hand, you can be sure that the provider will not influence the thing you want to contact, and maybe in some countries it is a big privilege, but in the normal relations with the provider, in normal countries, provider usually tries their best to protect their network, and for instance, to protect it from malware, etc. And here the ISP simply cannot do that. You are open to the world. whatever they answer, you will deal with that. And this will be also the problem of the network you will be using, especially if it is an enterprise network. You got malware and it spread over your network, and yeah, that's the result. So that's the impossibility to install access lists for recursive resolvers. So the recursive resolver is public, and that's it. Also, there is a complexity for the provider in diagnostics of the problem. Right now, if the user is calling a provider with some kind of complaint or malfunction, the stage of finding out if everything is good with DNS is quite quick. And it is quite simple for the call center employee to check if your DNS is working correctly. But if you start having different applications using different DNS and over different protocols, it becomes more complicated and more difficult for the support. Also, enterprise data leaks. If you are working for some enterprise and there is a big internal network with internal resolver with internal servers, and you have installed DOH, the browser will not be taken care if it is an internal server or not, and it will be asking there. So the data that you have for these servers with these kinds of names will leak there. It seems not to be a big problem, but it's still the leak of security data. Also, the complexities of content delivery network localization. Right now, Google, Facebook, and other global companies, they define from where the request is coming, and in the resolving, it provides you IP addresses that are closer to your place. So, for instance, if they have their servers worldwide, it makes no sense to use the server from the US if you are in Ukraine. But in order to provide you this address of the server which is nearby, they need to find out where you are coming from. And if you have come from 1111, for instance, it is difficult to understand from where exactly you are contacted that recursive resolver, and which server is more close to you. That's a difficult question to answer. And also there is a possibility of commercialization of DNS traffic if it is collected on centralized recursive resolvers. It's big data that one can process and sell without asking you. So these are the issues to which I've never heard any good answer yet. The only positive thing here is, well, what can this provide if you are installing your own recursive resolver and it is public and no one knows about it? And there is a chance that no one will find out about it. You will be able to use your resolver from anywhere in the world, and you will be getting answers from your recursive resolver, and you are sure that it works correctly. Now, Here I wrote Google Chrome, but actually I mean any Google service. So, tell manager of Google Public DNS team, he writes in one of his letters that Google would never ever combine DNS servers, DNS over HTTPS, with web servers. The problem is you can block as an ISP if you do not want to provide access to DNS over HTTPS. You can block an IP address, but you cannot block a port, because if you will block the port, your users will not see web. And right now the spread of HTTPS is quite broad, and one cannot use internet without HTTPS if you are just any user. So HTTPS has to be available. Google here promises that they will not mix those servers together. At least the public resolvers that will be providing DNS over HTTPS are available for blocking. And also there was the promise from Google Chrome, that they will not have a DOH resolver by default. So the browser by default will be working over usual DNS, so to speak. Now, if we come to Mozilla, that's slightly worse here, because we asked them many times, at least that's what I heard from them. They never promised not to have it by default, but there are these settings in Mozilla which are used under the general term TRR, and by default it is 0, which means we are using what is set by Mozilla by default. So right now, as a rule, it's usual DNS, although they have DOH possibility as well. But if you have set 5 instead of the 0, it shows that you intentionally want to use the usual DNS. So unless your Mozilla settings collapse, it will never use DNS over HTTPS. This is a bit outdated already. I mean, we have more of those right now. They are available, and if you wish, you can find many more places. That's basically it. Thank you. As far as I see, there are no questions. Yeah, it seems there are no